So we are discussing the assignment 8. Now in this assignment 8, you will see that we will be discussing some things. Now there are, the sir has discussed what you say, circle diagrams and all that. I will discuss it, but you will see that in in this questions, you will not find any application of that circle diagram. Okay. But I'll discuss it so that if in case some questions come, you can solve it. Okay. So in your assignment, is there circle diagram question? Like circle diagram means something like this, like you know, right? Okay, okay. I'll just discuss the theory of it in case if it comes in the exam. Okay. So let us start with this class. Okay. So, so now we will see some of the things like earlier we saw the equivalent circuit of the induction machine, right? So what was the equivalent circuit? It was something like this, that you had R1, JX1. Okay, so let me draw it a bit horizontally. R1, JX1. Then you have JXM. Then this is JX2 dash, and this is R2 dash by S. Now, what we are saying that let us suppose we are neglecting the stator impedances because stator impedances represent the stator loss. So we are saying that okay, neglect the stator core loss. Okay, so as soon as we neglect the stator core loss, we can neglect this parallel part. Okay, this JXM part we can neglect. Okay, now let us say we are also neglecting the stator this reactance and also the stator impedances. So we are neglecting all the stator impedances and stator losses. So if we neglect that, then we can represent it directly by a short. This stator part R1 JX1 is shorted, and JXM because this is the parallel connection. So if we have to neglect it, so we have to open the parallel connection. Okay. So in this way, we are neglecting the stator core loss, which was represented by the this parallel branch, and by the series branch, which was representing the stator copper loss and the stator some reactive losses. Okay. So we are neglecting all that. So if we neglect, then we are left with a very simple circuit like this, which is only having the rotor parameters, which is referred to the stator side. Because how we know it is referred to the stator side, because this is dash. Okay, so if it was only x2 and r2 by s, then we would have known okay, this is in the rotor side itself, but we have referred it, that is why we have this dash, x2 dash and r2 dash by s. Okay, so why we do this simplification is because if we do this simplification, then our calculations become simpler, right? We have seen in the previous assignment that there were huge calculations, right, involving the complex numbers. So if we make our circuit simpler like this, then we can get an approximate value of the torque value, and we can do the approximation. It will not be the exact answer, but it will make our life simpler, right, if we use this approximation. So you will see that if in the questions it is mentioned that you have to neglect the stator impedances, stator losses, if it is mentioned like this, then you have to go for this simplified equivalent circuit diagram. If it is not mentioned like this, that you cannot neglect the stator impedances, stator losses, then you have to go to the full circuit diagram, which is this. Okay. So you will see that in this questions, you will see that it is asked that we have to neglect the stator impedances and stator losses. So we will see the simplified equations. Okay. So, so first of all, because there is no stator copper loss, so we know in the previous power flow diagram, what was happening? Pin was there, and then the stator losses, which consisted of stator copper loss and core loss. When we took out those stator losses, then we are left with what? We are left with PAG. But you see, because there are no stator losses, then what is happening? This P in the stator input power is equal to PAG, which is the air gap power, because there are no stator losses. So whatever is the input power which is coming, it is going to the input of the rotor. Okay. Now from the air gap power, if you take, because rotor copper losses are still there, because we have not neglected the rotor parameters, right? We have neglected the stator parameters. So what is happening from the air gap power? If you take out the rotor copper losses, you are left with the gross mechanical power. Okay, this air gap power to the gross mechanical power part remains the same. Only difference is because we are neglecting the stator losses. So because this becomes zero, that is why in this we are saying that PAG is approximately equal to Pin. Okay, so this is one approximation which is coming because of neglecting these branches. Okay, series branch and the shunt branch. So we know what is this gross mechanical torque developed. We know that gross mechanical torque developed is this. So gross mechanical torque developed we have seen earlier. It is this gross mechanical power developed by 2 pi nr. And what is this gross mechanical power developed? We have seen that it is equal to 1 minus slip times of air gap power. We have seen this, okay, in the earlier class. So this is what we get. Now, NR can also be written as what? NR can also be written as so it can NR can also be written as 1 minus slip times of NS. So this 1 minus slip times of air gap power is there in the numerator. So this 1 minus slip and 1 minus slip gets cancelled. So you are left with P air gap 2 pi NS. This is the same as the previous, this expression is same, right? As the previously which we have seen. However, in this air gap power, what is the air gap power? It is equal to the 3 times of, but you see, we know that now what is the relation between the air gap power and the rotor copper loss? We have seen that air gap power is equal to rotor copper loss by slip, right? We have seen this is the relation between the air gap power and rotor copper loss. Okay, so you will see that this is how it is coming. So it is coming as 3I2 dash square R2 dash by S, because it is copper loss by slip times, okay, divided by 2 pi ns. And in the I2 dash, we can see now we are getting a very simplified expression, right? Earlier we were having this R1 JX1, then parallel to JXM, then we were having this also, but we are not having all that. Now what we are having? We are having in the I2 dash, we are only having this voltage divided by root over of this resistance square. So resistance in the system is only R2 dash by S. So R2 dash by S whole square plus the inductance in the system, which is X2 dash. So plus X2 dash whole square. Very simple. This I2 dash expression is now very simplified. Okay. So from this, if we substitute this I2 dash expression back in this place in here, so let us see what we get as the torque expression. Okay. So you see here, so let me just hide this. So you see, so in here, what we have done is that we have substituted in the place of I2 dash this expression, okay, which we have obtained. So if we substitute that, we will get this. So it was 3I2 dash whole square into R2 dash by S by 2 pi ns. So I2 dash we are substituting as V1 by root over of R2 dash by S whole square plus X2 dash whole square. But remember, this is I2 dash whole square. That is why this under root is getting cancelled out and this becomes V1 square. Okay, so here we have 3V1 square by 2 pi ns, and this is R2 dash into S. So if you see this in the, if we this we have this S, right? So if we multiply by S square in both numerator and denominator, so in this step, multiplying numerator and denominator with S squared. So if you do that, so this S square into R2 dash by S, so one S and one S in the S square will get cancelled. So you will be left with R2 dash into S divided by this R2 dash square plus S square X2 dash whole square. Okay. So like this. Now what we are doing, you are just dividing by X2 dash whole square. Okay. So if you divide by X2 dash whole square, now in this step, you are dividing both numerator and denominator by X2 dash whole square. Okay. So here, so let me just write that dividing the denominator and numerator with x2 dash square. Okay, so you will get this kind of an expression. Now here let us suppose we are substituting this as, let us say that some alpha is there which is equal to r2 dash by x2 dash. Okay, so here we are just substituting in this place of r2 dash by x2 dash as alpha. So you will see that you will get a very simplified expression. Okay. So in this simplified expression, what we are doing is we are substituting in the place of r2 dash by x2 dash as alpha. So what you are left with? You are left with s into alpha divided by s square plus alpha square, right? Because this part is not dependent on r2 dash by x2 dash ratio. It is what you say, it is independent of that, right? So wherever this ratio is there, you substitute alpha. So what you are left with? You are left. So you see in this torque expression, you have V1 square. So unless you are changing your applied voltage, this will V1 will remain constant. Generally in the questions, you will see that we have mentioned, right? You are applying this much of rated voltage to the machine. So that does not change that much. So what you will see is that this V1 will remain constant, and synchronous speed is anyway constant, because as soon as you declare the number of poles, so and frequency, so this synchronous speed also becomes constant. And x2 dash is the reactance at standstill, which is also constant, because it is when the machine is already designed, so this x2 dash value also gets fixed, right, in the machine. When you have decided the rotor windings, you have made the windings. So this part 3v1 square by 2 pi ns into x2 dash, this is, let us say, a constant k. So you will see that the torque expression is basically k into s alpha by s square plus alpha, where s can be any operating slip. Okay, so in if so you remembered here that alpha is r2 dash by x2 dash. Okay, so you will see that this alpha can be any, so alpha is fixed as r2 dash by x2 dash, whereas this s can be at any operating slip. So this is torque at any operating slip s. Okay. Now let us see what is the condition of maximum torque. So we know that maximum torque in this case, the maximum torque when it will occur, we know that from the maximum power transfer theorem, this load impedance should be equal to the Thevenin impedance. But here the Z Thevenin is only x2. So for maximum torque, r2 dash by x should be equal to x2 dash. Right. So this is the condition for maximum torque. Now here, instead of s, we are, so here you see for this case, s is equal to r2 dash by x2 dash, which is also equal to alpha for maximum torque, remember. Okay, so in this expression of torque, let us substitute this s equal to alpha. So let us say in the place of alpha, I am substituting s. So this is what? K into s square, because alpha is equal to s. So s into s is s square divided by s square plus s square, because here alpha and s are same for the maximum torque condition, remember. So what we are left with? We are left with k by 2, because s square by 2s square. So we are left with k by 2. So the maximum torque value is k by 2. Okay, so you see, we have simplified it so much, right? Earlier it was a complex expression. So now, because so here we, by neglecting this stator impedances and the stator core loss, we have simplified the value of expression of torque and maximum torque, right? So you will see that this assignment question is basically what you say, dependent on this expression only. Okay, so what we will do is we will just solve the assignment questions first, because right now I have discussed this, right? So it will be very fresh in your mind. So if we discuss the assignment questions, then you will be able to understand. After discussing the assignment questions, I will go to the circle diagram. Okay, so is there any doubt in this whole process, like in these two slides, whatever I have discussed? Okay, so let us now see the questions. You will see that this solution of these questions compared to the last class is very easy to get, because we are not doing very complex algebra, right? So if you know these relations, then you can easily solve the questions in this assignment. Okay, so let us see these questions one by one. Okay, so here the question is that let us say that we have a 8 kilowatt three phase 600 volt 50 hertz 10 pole slip ring induction motor. So maximum torque occurs at 15% slip. So maximum torque, basically we know that alpha is the ratio R2 dash by X2 dash, right? And this and when the maximum torque occurs, S is also R2 dash by X2 dash. This is for maximum torque. Okay, so so this ratio is given as 15%. Okay, remember this. This alpha is also 15%, and this slip when the maximum torque occurs, this is also at 15%. So 15% in the decimals is written like this: 15 by 100, so 0.15. And it is said that the maximum torque value is 2.5 times the full load torque. So T max is 2.5 times T full load. Okay, so this is the two information which is given to us. And now you see they are saying stator impedances, magnetizing current, core loss, and mechanical loss are negligible. So we know this is which circuit. This is the simplified circuit, right? Because we are neglecting the stator impedances and the core losses. So we are neglecting it. So it means we are referring to the simplified circuit. So they're asking you to use the what you say this approximation values. Okay, now they are saying that the load torque does not vary with the speed. That is just additional information. Now they're asking you to find the full load slip. Okay, so first of all, we know the slip at maximum. So this is the slip at maximum torque, right? So what is the so we know what is the maximum torque expression. So if you see here, maximum torque expression in terms of this constant is k by 2, right? So let me write this. So T max is k by 2, right? And what is this expression of this torque at any slip? So torque at any slip, which can be a full load slip also, is this k into s alpha by s square plus alpha square. This is the expression. So let me just write this: k into s alpha by s square plus alpha square. So let us say we are interested in full load, so let us say full load. So if we calculate for s, then whatever value of s we get it for full load. Now let us take the ratio of this. So let us take the ratio of let us say te full load by t max. So if we take the ratio, so what it becomes, this is k into s alpha divided by s square plus alpha square, and in the denominator it becomes k by 2. So k, and this 2 goes up because k by 2, then in denominator if it is 1 by x, then it goes up. Okay, so like this, k by 2. So here k gets cancelled because they are the same thing. We have seen that this k is independent of the operating condition, right? It is dependent on the what you say V1 is fixed, because V1 in both the full load torque and the maximum torque case, it remains the same. NS remains the same. X2 dash is the standstill. This rotor inductance referred to stator, this also remains the same. So this K in both the cases, in the full load torque case and the maximum torque case, it is the same. That is why we were able to cancel it. Okay. So what we are left with? So first of all, in the question, you will see that we are given this relation also, right? That T max is equal to 2.5 times of T full load. So T full load is 1 by 2.5. right? Because in T max place, you can just write 2.5 times T full load. So T full load will get cancelled. So you'll be left with 1 by 2.5. And here we are left with 2s alpha by s square plus alpha. Now we know what is the value of alpha. Alpha is 0.15. So we know alpha. Okay. So 2.5, this ratio is also known. So what is only left? So in this quadratic equation, we are also, if you come here, so this is the quadratic equation in S. Okay. So we have to solve this quadratic equation in S. Okay. So how you will solve in the exam? So you know this will be SC will be equal to plus minus. So this will be minus B plus minus root B square minus 4AC by 2a. When you are writing the expression like this, as square plus bs plus c equal to 0. Okay, so here you can see that in the place of b, we can just substitute. Okay, so this is the what you say, solution of this quadratic equation. So if you replace the coefficient, so this minus b plus minus root b square minus 4ac by 2a is for this quadratic equation, as square plus bs plus c. So if you compare the coefficients of this as square plus bs plus c with this equation, which we have obtained by doing the cross multiplication here, same expression, okay, you will get it here. So you can substitute and solve for S. So you will see that you will have two solutions of S. Okay. So one is this, you will see in terms of alpha. So this is, they have written in terms of alpha, you will get it in directly in number. Okay. If you substitute this alpha value here. So one expression will be this, or one expression will be this. So which one we have to take? So first of all, if suppose you get one negative slip and one positive slip, okay, so you will know that you do not have to take the negative slip. Okay, because here we are talking about the motoring mode. So in motoring mode, slip is always positive. Okay, so if suppose you get one slip as negative and one slip as positive, so straightforward you can say that okay, my slip positive is the correct answer. But in this case, you're getting both the slips as positive. So which one you have to take? So you will see that the full, so for solving the full load slip, you will get two answers. One is this 0.0313. Okay, so so if you solve for this, so if you solve this quadratic equation, you will get one 0.0313 and one, so this is how much? So let me just write it using the calculator. So this is alpha is 0.15. So 0.15 times of 4.7912. So this is 0.718. Okay. So this is 0.718. So in these two slip, which is the full load slip? So we know that maximum torque slip is 0.15, right? Now you will see that the full load slip and the maximum torque slip, if you compare, so you remember this, that the full load slip should be less than maximum torque slip. Okay, so in the two solutions, maximum torque slip is 0.15. So compared to 0.15, one is 0.0313 and one is 0.718. So you will see that this 0.718 is not the correct answer. It has to be less than 0.15. Okay, so the correct answer is because you see, I will tell you why. So this is the torque versus slip characteristics. So it is something like this. So you will see that your maximum torque is happening at somewhere value around, let us say in this case, 0.15. Okay. Now, if suppose you increase your slip, so this is slip equal to 1. Okay. So let us say in this case, this is slip is equal to 0.718. So 0.718 slip means very small value of torque, right? So you will generally not operate your machine at such a low torque. Okay. That is why you will see that this is little bit less than this what and also this is unstable region. You will see that in the sir's lecture he has discussed that this is unstable region. Generally we operate in this region. Okay, this is stable region. That is why this full load torque should be somewhere less than this slip value. Okay, that is why you have to take this so that you have to ensure that your full load torque slip should be less than maximum torque slip. Okay, this is important. So after solving, so two things you have to ensure. One thing you have to ensure is that your slip should be positive and your calculated slip full load torque slip value should be less than maximum torque slip. If you can ensure these two things, then you will see that you will be left with one of the solutions. Okay, so in the quadratic equation you will get two solutions, out of which you will select only one solution on the basis of two things. One, it should be motoring mode, slip should be positive, and the other thing should be that the full load torque slip should be less than maximum torque slip. Okay, so using this you will get your full load torque slip as 0.0313. Okay, so what you need to remember is, you need, for solving the questions, you just need to remember this thing. Okay, this that torque is equal to k into s alpha by s square plus alpha square, where this k value is this value. Okay, so you can remember this because sometimes they may ask you to calculate the torque directly, but they will generally not ask questions like that. You may need to use this equation in this form only, you will see. Okay, so you can just, for this whole assignment, you just need to remember this expression. Okay, I'll just say that you have to remember this one. And you may not even need to remember this. You may just need to remember, you can also like just think that okay, this is air gap power by 2 pi ns, and air gap power is 3 I2 dash square R2 dash by s. So in the place of I2 dash, if you substitute this, so you will be you can get this expression. Okay, so that also you can do if there is difficulty in remembering. So this question clear? This question is very simple. Huh. Okay. So after that, what you do is you cross multiply this. So what you will be left with, s square plus alpha square is equal to 5s alpha. This 2.5. So this is s square minus 5s alpha plus alpha square equal to 0. Actually, they should not use the term k, because then it gets very misleading. Because this k is already used. So don't just look at this. You can see this. Okay, this is minus 5s alpha. Yes, this one. Okay, 5 alpha. B will be 5 alpha. So B is basically minus 5 alpha. I'll write it for you. A is 1 and C is alpha square. Hmm. So you have to just substitute this value of ABC in this expression. Hmm. Okay. Huh. So now moving to the next question. Now this next question is the continuation of the last question only. They're asking you to estimate the full load speed. So what is the full load speed? So because we have obtained the value of full load slip, so full load speed is nothing but NR, which is corresponding to full load speed, is equal to 1 minus S into NS, where S is slip corresponding to full load. Now, we have already obtained the slip corresponding to full load, which is you have to remember that when you are entering the answer in percentage, you have to multiply this by 100. Okay, then you have to answer in percentage as 3.13%. But when you are using it in the formulas, you have to use it in this fraction way only. Okay, this fraction form. So this is 0.0313. So here you put 1 minus 0.0313 into ns. Now what is ns in rpm? So ns, because they're asking in rpm, so we will just substitute ns in rpm. So what is ns in rpm? It is 120 into f by p. Now what is this 120 into f by p? So this is 120, f is 50 hertz, and this is 10 pole. So you just take this out. So you will be getting this as 600. Basically 600 RPM is the NS. So if you do this, you will get this answer in RPM. Okay, so this was simple question. You just have to solve the previous question properly and then use the previous question slip in this question to get the full load speed. Okay. Now, in the next question, you have to estimate the full load torque. Now, what is the full load torque? So, full load torque is basically shaft torque by omega r. Okay, so I'll write these things. So, what is shaft power, not shaft torque? Sorry. So, this is shaft power. So, what is shaft power? We know shaft power is basically um, so this is gross mechanical power minus the mechanical losses. Okay, so and what is the gross mechanical power? It is your so here, so you see, I'll do that. So first of all, what we see is that the mechanical losses are negligible. Okay, so these mechanical losses you can neglect. So this is equal to gross mechanical power. Okay, so you can do it in two ways. One way is that if you see that you have written, you find this 8 kilowatt, three phase, 600 volt, 50 hertz, 10 pole slip ring induction motor like that. So you just know that this 8 kilowatt is the rated power value. Okay, rated power value or full load. So basically rated power or full load power. Okay, when the question is given like this. So you know that, okay, this is your rated power. So what you can do is you can just get the full load torque by rated power by omega r, where omega r is in radian per second. So omega r in radian per second is equal to 2 pi nr, which is in rpm by 60. Okay. So this is the thing which you have to substitute here. So this is one way of doing it. Now, if you see that in the question, this 8 kilowatt is not mentioned. Let us say that this 8, if this 8 kilowatt is mentioned, then you have to use it like this. Okay. So when power is mentioned. So now this one, when power is not mentioned. Now here, what is the gross mechanical power? We know it is air gap power minus 3 I2 dash square R2 dash. Air gap power minus the copper loss is equal to gross mechanical power. So if I write this in terms like this, so this becomes 3I2 dash square R2 dash by 1 by S minus 1. So this becomes 3I2 dash square R2 dash 1 minus S by S. So we know the slip at full load torque, but we don't know the copper loss, remember. So you will see that either of the two things will be given to you. Either this rated power, full load power will be mentioned, or copper loss in some form will be mentioned. Okay. So you have to understand that which way you have to proceed. Okay, either you have to proceed by when the power is mentioned, then you know that okay, this is rated power by omega R. If power is not mentioned, then you will see that copper loss in some form it will be mentioned. Okay, so you have to obtain the copper loss, which is this 3I2 dash square R2 dash, and slip you already know 1 minus S by S. Okay, so this is how you can solve this. So what is your rated power? So we know that from the question, the rated power is 8 kilowatt and omega R is in radian per second. But what is the relation between radian per second and RPM? It is 2 pi NR by 60. So this is 2 pi into NR by 60. Now NR we have solved in the previous question. So NR is 581.215. Okay. So we'll be substituting this NR value 581.21 by 60. Okay. So if you do this, you will get this value. Okay. This value they have found. So because they have mentioned the power, so we will use this method. Okay, if they would have not mentioned the power, then we would have used this method. Okay, so but you will see that by mentioning this power and all, they will ask you to back calculate these things like copper loss and all these things. They will ask you to back calculate. Okay, so because we know because we know the relation between the this shaft power and this copper loss using this ratio, right? So you will see that in the upcoming questions they will ask you to solve for the copper loss if they have given you 8 kilowatt. But if they have not given you 8 kilowatt, they have given you copper loss, then they will ask you to find the shaft power. Okay, either of the two they will do. So, okay, so this is the two ways in which you can find this full load torque. Okay, depending on the information which is provided in the question. So this is how you will get. So this is in Newton meter. That and another thing is that when you are writing this divided by omega r, you have to be very careful. It has to be in radian per second. Okay, so you have to convert your RPM to radian per second. Okay, this you have to do. Then only you will get the answer in proper units, proper SI units. Okay. So these are the things which you have to note in this question. Now they're asking you to estimate the maximum torque. So you see they have already given one information, right, in the question that the relation between the maximum torque and the full load torque is this 2.5 times, right? So maximum torque they have said in the question is 2.5 times the full load torque. So full load torque we have already solved in this last question. So you just need to substitute this and put this as 2.5 times of 131.43. Okay, so you will get this answer. These are easy questions. You just have to remember these relations. Okay. First of all, you need in this whole assignment, you will see that somehow or the other, you will be in the first way when you have to proceed in the first part, because you will see that these questions generally come in multiple parts, right? Even in the exam also, you will see that this will be like first part of the question, second part, third part, so on. So you will see that in the first part, you will need to proceed by using this formula. Okay, so I'll just highlight with some different color for your thing. So you will be proceeding by using the relation between this formula and this formula. After that, it is your regular things which we have seen in the earlier assignments also. Okay. So this and this for this assignment is important. Okay, these two are the same. I meant this maximum torque thing. Okay. So just erasing this. So these two are important for this assignment. Once you are able to solve the first part using this, the remaining is very simple, which we have done multiple times in the previous questions also. Like as soon as you, so in the question they gave the maximum torque slip. Now you, by using those two formulas, you found the full load slip. Now after finding the full load slip, you know what is the full load speed. Very simple, right? Now then you know what is the full load torque. Full load torque, as I discussed, it should be rated power by omega r. So 2 pi nr we found in the previous question itself, and full load power is given in the question as 8 kilowatt. Okay, so like this. Now maximum torque and full load torque are related very straightforward like this. So these are all simple things. Okay. Here there is a little bit of trick. You have to read the question and understand that whether this is what is given, either the this output power is given to you or the copper loss in some form is given to you. Okay, so this you have to understand by reading the question and then proceed in either of the two ways which has been discussed here. Now they're asking you to estimate the starting torque. So this is also again the application of the same formula. So what is the relation? So we know that T max from the formula in the second slide is K by 2. Okay. And T at slip S is equal to K into S alpha by S square plus alpha square. Okay. So if you take the ratio of the two, so this is, let us say T, this is equation 1 and this is equation 2. So let us say 1 by 2. So this is TE at slip S divided by T max. So you get what? You get, so if you take this ratio, you get 2S alpha by S square plus alpha square. Now you see, because they're asking you at starting torque. So for starting, what is the slip? Slip is equal to 1. So T at S equal to 1 by T max. So this is 2 alpha by 1 plus alpha square. Where what is alpha? We know that the slip at which the maximum torque occurs. This is R2 dash by S, slip at maximum torque, which is given in the question as 15%, 0.15. This is also equal to alpha. You can see the derivation. People who have come late, you can see the derivation, that in the derivation, this alpha has been considered as R2 dash by S only. So in the question, when they gave you that maximum torque occurs at 15% slip, so they have given you the value of alpha. Okay. So here you just put it 2 into alpha, which is 15% by 1 plus 0.15 square. So this torque T max is already solved, right? T max we have already solved in the last question. So this is 328.59. So this ratio, so I'm just writing here. So T at slip 1 divided by T max value is 328.59. 328.59 is equal to 2 into 0.15 by 1 plus 0.15 square. So you can just cross multiply here. So you will get T at slip 1 is equal to 328.59 into 2 into 0.15 by 1 plus 0.15 square. So if you do this, you will get this answer. Okay, this is the starting torque slip. So this is how you can solve this. You just need to know this and need to know this. Other than that, it is the relation in between T max or T at any slip. It could be at starting, it could be at full load, it can be whatever. So you can find anything. You can find the, if they have not given the relation between the torque, then you can find the value of the torque. Like here in this case, we had to find. In the first question, they have given the relation between the two torques, like full load torque and the maximum torque, and you were asked to find the value of slip. Okay, so you can do that. Huh. Plus 1. This is 1. This is 1. 1 plus, so this is s square plus alpha square 2s. So we are substituting at slip 1 because we are we are finding it at starting, right? So at starting slip is 1. So we just put s equal to 1. So this is 2 into alpha by 1 plus alpha square. No, this is not the starting slip. This is, so they have, no, r2 dash by x2 dash. Hmm. Because this is the maximum torque slip. So we know that maximum torque slip is given, and that we have seen is also equal to alpha in the question, in the starting when we were deriving, right? So here when we were deriving, you see, we took that, so Sir has also considered that this alpha is R2 dash by X2 dash when he was deriving these formulas. And then also maximum torque occurs when slip is also equal to R2 dash by X2 dash. So this slip at maximum torque is equal to alpha. Okay. Ha. So that is what we used here. Basically, they have given you 15% slip is maximum torque, which is R2 dash by X2 dash, and this is also equal to alpha. That is what they have given you. They have basically provided you alpha so that you can solve these things. Okay. Hmm. Now, let us see the next question in this series. So here we have to now estimate the full load copper loss. As I said, right, either of the two things will be mentioned to you. Either the copper loss will be mentioned or this output power will be mentioned. Okay, so they have given you the output power. Now they're asking you to calculate the full load copper loss. So let us now see what is the relation between the this output power and the copper loss. Okay. So what we know that air gap power, okay, so this is the air gap power minus the rotor copper loss. So if I take out the rotor copper loss from the air gap power, then we get what? We get gross mechanical power. Now, from the gross mechanical power, if I take out the mechanical losses like friction loss, windage loss, okay. So if I take out the mechanical losses, I'll be left with shaft power. So this was the power flow. Okay. Now they're saying that mechanical losses are negligible. So mechanical losses are negligible means what? Your gross mechanical power is equal to shaft power. Okay. So this is given as 8 kilowatt. Now, what is gross mechanical power from this side? So gross mechanical power from this side is air gap power minus the rotor copper loss. This is the gross mechanical power from this side. Now, what is the air gap power? We have seen in the earlier classes that air gap power is 3 I2 dash square R2 dash by S minus 3 I2 dash square R2 dash. Okay, this is equal to shaft power 8 kilowatt. So we know that the rotor copper loss is 3 I2 dash square R2 dash. Okay. So if I take this 3 I2 dash square R2 dash common, then we are left with 1 minus S minus 1. is equal to 8 kilowatt. So this is copper loss, okay, into 1 minus S by S is equal to 8 kilowatt. So what is the copper loss and this output power relation? So copper loss, so I'm just writing here only. Copper loss is equal to, so just let me take this here. Copper loss is equal to 8 kilowatt into S by 1 minus S. And they're asking you to find the full load copper loss. So what slip you will substitute here? So copper loss, so I'm just writing here that it is equal to 8 kilowatt into slip by 1 minus S. So here we have to substitute the value of full load slip because they're asking you to find the copper loss at what you say this full load slip value, right? Full load rotor copper loss. So we have seen that what is the full load slip. Very first question we have solved for this. So full load slip was 0.0313 or 3.13%. 0.0313 we have to put in the place of S. So this is 8 kilowatt to 0.0313 by 1 minus 0.0313. Okay, so you will get this value. Okay, you just for this question you need to remember this power flow. Anyway, you need to remember the power flow because the previous assignment we have used this power flow so many times, right? So in order to solve this, you need to use this power flow. Okay, so this was a simple question. Just need to derive it like this, and you can just write the relation between the copper loss and the output power like this. Okay. Actually, this relation is between the copper loss and the gross mechanical power. But here, because we are neglecting the mechanical losses, so we can just write that, okay, gross mechanical power is 8 kilowatt, and we can do it like this. Okay. So this is the how you can do it. So at any point of time, if there is doubt, please ask. Is there any doubt in till now for anyone? If there is doubt, so please raise the doubt. Okay, then I'll clear it. So going to the next question. Now in the next question, we have to estimate the ratio of starting current to full load current. Okay. So how to do this? So we know the relation. So what is the starting torque? So we know that starting torque. First of all, let us just write the simple expression of torque. Okay, starting and full load we will see later. But what is the torque actually? We have seen that torque is equal to 3 I2 dash square R2 dash by so R2 dash is there, and that's 1 minus S and 1 minus S gets cancelled. So you are left with so it is like this. You see here. So this is 3 I2 dash square R2 dash by S divided by 2 pi ns because this becomes air gap power by 2 pi ns. Okay. So this is R2 dash by S. So just I have to R2 dash by S by 2 pi ns. Okay. So this is a torque at I2 dash. Now let us say that we write starting torque. So starting torque will be equal to 3 into this I2 dash will become I2 corresponding to starting current because then I2 is what? I2 is V by root over of R2 dash by S whole square plus X2 dash whole square. Okay. So this is the thing. Now, depending on whether this slip is corresponding to starting torque or whether this slip is corresponding to full load torque, this I2 current will vary because S value varies for the two torques, right? Starting value and the full load value slip. So because those two slip varies, I2 value varies. So I am just writing because we have to we do not need to find the exact value of the starting current. We just have to find the ratio. So I am expressing it in terms of I2. Like let us say that the I2 current corresponding to slip equal to 1 is I2 starting current. Okay. So this is starting current square into R2 dash by S. Okay, S is equal to 1 for the starting torque divided by 2 pi ns. And what about full load torque? Full load torque is 3 times of, then again instead of in the I2 expression, if I put the slip as the full load slip, then I will get the current corresponding to full load current. So that is why because I have to find the ratio, so I'm just writing it as full load current square into R2 dash by S divided by 2 pi ns. Now, remember that this S value, now we have to put corresponding to the full load torque. Now, what is that full load slip? So, full load slip is this much, 0.0313. Okay. So, if I take the ratio of the two, starting torque by full load torque, so if I take the ratio of 1 is to 2, so if I do that, so what I get? I get starting torque by full load torque as 3 times of starting current square into R2 dash, because S is equal to 1, so R2 dash by S with S equal to 1 becomes R2 dash, divided by 3 into full load current square into R2 dash by 0.0313. Now you see that 2 pi ns and 2 pi ns is common in both. So if I take the ratio of the two, 2 pi ns will get cancelled. Also this 3 will also get cancelled. This R2 dash will also get cancelled. And remember this starting torque and full load torque we have obtained separately. Okay. So starting torque we have found in one of the questions. So in this question we have found starting torque, which is this 96.41. And full load torque we have obtained as 131.43 in this question. So we have to write these values. Okay. So, so this is equal to 96.41 divided by full load torque. So full load is 131.43. Okay. So this is the thing, and here it is starting current square, and this 1 by 0.0313 will go in the numerator, 0.0313 divided by full load current square. So what you can do, you can just cross multiply. So this 0.0313 you can cross multiply and send it down. So this will become 96.41 divided by 131.43 into 0.0313 is equal to starting current square by full load current square. And then you can take the square root on both the sides. So if you take the square root on both the sides, it becomes starting current by full load current, and this whatever this fraction is there, it's square root. Okay. So if you do this, you will get this answer. Okay. Um, is this solution understandable? Did you understand what I'm saying? How to solve this? Is there any doubt in this question? Hmm. Okay. So other people also, this is clear, right? So at any point, if there is doubt, please raise the question. Okay. So that I can clarify your doubts. Okay. So now, um, Let's go to the next question. Now in this next question, what we have to do is we have to estimate the ratio of current at maximum torque and full load current. Now we will proceed in the similar way, but here I'm just right. So here also again I'll start. So I'll start like this. That first I will write the torque. Okay. So this torque is 3 I2 dash square R2 dash by S divided by 2 pi ns. This is the general expression of torque. Now here we have to take the two values of current, maximum corresponding to maximum torque and full load torque. So I'll just write, so this is, let us say, what is this maximum torque? So this maximum torque is equal to 3 times of uh, current current at maximum torque. Let me write this. Current at maximum torque square into R2 dash by S, where we have to place slip as maximum torque slip divided by 2 pi ns. Okay. And then we have to say full load torque. So what is the full load torque? It is 3 times of full load current square into R2 dash by slip corresponding to full load. So this is slip full load, slip T max. Okay. Divided by 2 pi ns. Now you just take the ratio of the two. 1 by 2. So what you will get? You will 3 and 2 pi ns in both the ratio. If we take, it will get cancelled in both the equations. So you are left with current at maximum torque square into R2 dash by S torque max divided by full load current square into R2 dash by S full load. This R2 dash and R2 dash will also get cancelled. Here slip corresponding to torque maxes, we have seen it is 15%. So this is 0.15. And full load slip is, we have calculated in the first question. This is 0.0313. Okay. And the ratio of the two torques, we have seen that the maximum torque is 2.5 times the full load torque. So maximum torque by full load torque will become 2.5. Okay, it is given in the question that the ratio of the two torques is 2.5. Okay. So again, you have to cross multiply and solve properly. So if you do that, you cross multiply and then take the root. So maybe I'll write the another step. So here it is current at maximum torque square by full load current square. Now here this will become, you see this is 1 by 0.15. So 0.15 will come in denominator here and 0.0313 will go in numerator. And after the cross multiplication, it will become 0.0313 into 0.15. Okay. So what you do, you take the square root on both the sides. Okay. You take the square root on both the sides. So if you do that, you will get this ratio of the current as this value. So if you substitute, you will get this value. Okay, 3.46, whatever they have given. Okay, so these two questions are similar. same questions. You just have to, that is why I said you have to remember this basic expression of torque, which is getting continued from the last three assignments. So it is easy, right? Then there are no new, what you say, formulas coming. It is just same thing which is getting repeated in some form or the other form. So you just remember this, okay? So now we have to find the full load efficiency. So what is the efficiency formula? Efficiency is output power by input. Now what is this output power by input? So output power is given in the question as 8 kilowatt. And input is what? So stator input, you will see that in the new power flow diagram, if you go here, in the new power flow diagram, stator input is equal to air gap power, right? So this is air gap power because we have neglected the stator losses. So input power is equal to air gap power. So I am writing it as air gap power. Okay. So this is air gap power. And what is this air gap power? Air gap power is equal to, so it is like this, that you have air gap power here. This is rotor copper loss. And then you have gross mechanical torque. And then from gross mechanical torque, you take out mechanical losses. Then you are left with shaft power. But you will see that shaft power or output power. Okay, shaft power or output power. Now you will see that this mechanical losses is zero in the question. Mechanical losses are negligible. So this gross mechanical power is equal to output power or shaft power. And so gross mechanical power, I meant, not the torque. Okay, gross mechanical power. Now, what is gross mechanical power? So gross mechanical, so here we have to write air gap power. And what is the relation between the air gap power and gross mechanical power? It is gross mechanical power plus rotor copper loss. So this is 8,000, and gross mechanical power is shaft power because this mechanical losses are zero. So this is same. Okay, they are same. So that is why I'm writing gross mechanical power as shaft power as 8,000 plus the rotor copper loss. The rotor copper loss we have seen in one question, right? We have find it out. So this is the rotor copper loss. So rotor copper loss is 258.548. So they are asking you to find the full load efficiency, means they're asking you to find, you have to substitute the value of rotor copper loss corresponding to full load slip. Okay, so that we have already seen. So it is like 258.5. Okay, so if you take this ratio and multiply by 100 because they're asking in percentage, so this is what you will get the answer. Okay. So you have to remember this simplified equivalent circuit power flow diagram. Okay. Just have to remember that air gap power is equal to input power because there are no stator losses. Okay. Stator losses are not there. So that is why input power is equal to air gap power. Okay. So this is what you have to see in the simplified circuit. Now, there are next set of questions. Now, in this next set of questions, what you have to do is they're asking you that this is the same machine. Now, in the same machine, they're saying that, okay, slip ring induction motor is same. Now, the rotor resistance is made 4.5 times of the old rotor resistance. So, this is the change which they have made. So, now this R2 dash new is equal to 4.5 times of R2 dash old. Okay. That is the only change. Now they're asking you what will be the slip at which the new maximum torque will occur. So they have said earlier that okay, this slip is like 15% slip maximum torque. So earlier maximum torque occur at slip is equal to 0.15, which is equal to R2 dash old by X2 dash. Now, new maximum torque will occur at slip R2 dash new by X2 dash. R2 dash new is how much? 4.5 times of the R2 dash old. So 4.5 times of R2 dash old by X2 dash. And we know from earlier that R2 dash old by X2 dash is 15. So 15%. So 4 into 0.15 will give you how much? 4.5, sorry, not 4 into 0.15. So this is 4.5 into 0.15. So you will see it will come out to be 0.675. But they're asking in percentage, so you multiply by 100. So in percentage, it is 0.675 into 100%. This is 67.5%. Okay. So this is also a simple question. You just have to remember that okay, this much times it has increased from the earlier value. So just have to multiply this in the previous slip. Okay. So now moving to the next question. Now we have to estimate the new full load slip. You can do it in two ways. So how you can do it is that see, they are saying that the load torque is unchanged. Load torque is unchanged means TE full load is unchanged. Okay. And we know that TE max also is unchanged, right? So when we add external resistance, what happens to the torque slip characteristics? So let us say this is the torque slip characteristics at one value. Okay. So let us say this is at alpha old. Now, alpha new, we know that when we add external resistance, so what happens is that this torque slip characteristics, it shifts like this. Okay, it just shifts. This value remains the same. Okay, so this is alpha new. So T max in both the cases remains the same. So T max also is unchanged. Okay, so you will see that the ratio which we were taking, right? This T max, or let us say, so T max was how much? T max was K by 2. T at any slip is equal to K uh, K into S alpha by S square plus alpha square. Now remember that this value of alpha has now changed. Okay. Value of this alpha, because the slip at which the maximum torque occurs is changed because of adding this external resistance. So it has become now 0.675. Okay. So this is 0.675. Okay. So this is the change. So this is K into S alpha by S square plus alpha. So if I take the ratio of the two, 1 to 2, so T full load, slip at full load. Okay. Full load by T max if I do, so it becomes 2S alpha by S square plus alpha square. Okay. Where your alpha is 0.675, and because TE full load is unchanged, T max is unchanged, so this, because the data is the same. Okay, this question is having the same data. Okay, so this ratio was 2.5 times, so this ratio does not change because these two are not changing. So this is 1 by 2.5. Okay, so if you do this, you cross multiply, so you will get S square plus alpha square minus 5s alpha equal to 0. So this is your quadratic equation where now the alpha is 0.675. Okay, so this is 5 square minus. So I just want to solve this. So after solving, I just want to cross check whether they have given it directly. Okay, I just want to verify whether you can do it directly, and by this method, the both should come the same because this is the exact way of doing it. Okay, let us see that whether by solving it exactly and by using this shortcut, do we get the same thing or not? Okay, so let me just verify this. So I'm just solving for this 6.75. So this is 3.375s plus 0.675 square, right? So this is 0.455 equal to 0. So I'm just using the calculator. You can do it like this also, because in the exam you will need to do it like this. But because I'm short on time, so I'm discussing it by doing it in the calculator. Okay, so let me just put this. Then
Sakshi, in calculator, how do we do this? Sorry, basic question.
no, no. This here in our scientific calculator. See, you actually in the exam you will not get the scientific calculator. Okay, you will be given the normal calculator. So in the normal calculator, you have to do it in this way. Okay, there is no other way. But if you are asking in general for doing in the scientific calculator, what you do is you how do you select complex operation? You go to mode, right? So there is an equation. They will give like this: x square plus bx plus c equal to 0. Now you go inside there. So inside when you go, they will ask you to enter the value of a. Then you enter the value of a. Then click equal to. Then they will ask you enter the value of b. Then you will be enter the value of b and then click enter. Then enter the value of c. Then you will enter the value of c and then click enter. After entering these three values, they will give you a solution like this: x equal to this. Then again, if you again you and press enter, then you will again give you x equal to this value. Okay, like this. Okay. So, but in the exam, you will be required to do it like this only. Okay, there is no, because in the gate calculator, the calculator which you get for exam, it does not have this modes. Okay, you cannot do this mode. So like how in the complex operation you had to do this, na, that complex conjugate, multiplying and simplifying. So like that only you will need to do here. Okay, so huh. Okay, so a is how much? And C is also 1. Okay, so divided by 2. So it is this. Okay, so this is 4 plus or minus 16 square is 256 minus 4 by. Huh. Oh, okay, B is 4. Okay, okay. So just let me. Huh. 16 minus 4 by 2. So this is like this. So 4 plus minus 16 minus 4 is 12 by 2. So what I'll do is 4 plus or minus, I will write it like this. So this is 4 into 3. So I'll take out 4. So it will become 2 root 3. This is 2. So this is basically what? 2 plus or minus root 3. So this is 2 plus or minus 1.732. So you have 3.732 and the other one. So maybe this one is your right option. Okay.
We should not
No, 2 minus 1.7 because our slip what we are calculating the full load slip it should be less than alpha. Yes, yes. Okay. 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 So what I was saying, so I'm just trying to find it in the calculator only, uh, this equation, okay, because they have given some shortcut, but I'm not very sure about this shortcut. You can do it like this or not. So I'm just solving it and then I'll compare whether you can do this directly or not. Okay. So let me just do this. So here I was doing this 0.455. Okay, so you are getting this. Okay, so what you are getting is you are getting one slip as 0.14 and the other slip as very high value 3.234. So naturally we do not take the higher value because this higher value of slip is like 300%, which is like very absurd, right? Because your slip varies from 0 to 1. So this is not the correct option. This is the correct option. Okay, slip is equal to 0.14. So see, I you can do it in this way in the full method in which I have done. You will find it as 14%, or you can also do it in this way. So what they have done is they have just said that okay, the previous full load slip was 3.13 percent. So if I am finding the new full load slip, so it basically becomes how much they are saying that you are just like how you multiplied 4.5 times the previous what you say this maximum torque slip. So similarly here what you are doing this new full load slip is equal to this 4.5 times old full load slip. I'll tell you why. Okay. So this is actually interesting thing. I'll tell you one interesting thing which I have noticed. Okay. So what is happening? So okay, just let me make a new slide and tell this interesting thing. Okay. So so here so here what is happening is that uh, this is your torque slip characteristics, right? So this is the torque and this is the slip. Now, this was the old torque slip characteristic. So I'm writing it as T old. Now, what is happening to the new torque slip characteristic? So this is at slip is equal to, so this is slip is equal to 0 and this is slip is equal to 1. So what is happening to the new torque slip characteristic? So it is, okay. So you see, so when we added this, so this happened, so let me just write it with other color. Okay, so when was this T max happening in for the first case? T max is happening at slip is equal to, so this is happening at slip is equal to R2 dash by X2 dash. Okay, now what about this blue one, which is the new one? So this is happening at slip is equal to R2 dash plus R external by X2 dash, where it is mentioned in the question that rotor resistance is made such that it becomes 4.5 times of the original value. Okay, so they are saying that R2 dash plus R external equivalently becomes 4.5 times of R2 dash by X2 dash. So what is happening? So So it is getting shifted by 4.5 times the factor, right? On this x-axis, basically what is happening, this torque slip characteristics is nothing but it is shifting in the x-axis towards this towards the right direction. So the factor by which this is shifting is 4.5 times. So this is what? So this is 4.5 times of r2 dash by x2 dash. Okay, this new point. So similarly, this uh, T max. So let us say T max was T max is T full load. So let us say this T full load was happening here. So let us say this is at some value uh, alpha FL old. Okay, full load old. Alpha nahi bolte hain, but otherwise there will be confusion because alpha is something else, right? In our discussion. So let us say this is SFL old. So this is SFL old. Now see, the ratio by which it has shifted, the maximum torque has shifted on the x-axis. By the same ratio, this also has to get shifted, right? So what will happen that this SFL new will be 4.5 times of SFL old. It's very interesting, it will save you a lot of time if you understand this like this. Like, see, you can do this all this solution and you will get the same answer. But if you think logically, what is happening, that this torque slip characteristics is getting shifted in the x-axis by this 4.5 times. So whatever was happening at, let us say, it was happening at maximum torque was happening at, let us say, alpha old. So now alpha new is such that maximum torque is now 4.5 times of alpha old. Similarly, you will see that this, let us say this full load torque is FL old, SFL old. So this SFL old is like this, and SFL new you will see will be some value such that this SFL new is 4.5 times of SFL old, because the shift in x-axis will be what you say observed in the same way in which it was observed in maximum torque, right? For maximum torque, how the slip was getting shifted, it will also be observed in the same way for the full load slip also. So that is why you can do it directly like this also. Okay, is this discussion clear what I'm saying? So
Yeah, yes.
ha, so that is why this one you can do directly. Okay, if you see that, okay, uh, if you know that the factor by which it is getting shifted in the x-axis remains the same, so you can just take that into consideration and directly find the full load slip by multiplying the factor value into the old slip value. Okay, you can do this for any slip. Okay, so it can be full load sleep, it can be half the full load sleep, it can be 2 times the full load, whatever is the value, you can do it like this. 2 times the full load will not happen because 2 times the full load will exceed the maximum torque. It will be some like 80% full load, 90% full load. It can be anything in the question. Okay, so you can know this, that the factor by which the this slip value of full load torque is getting maximum torque is getting shifted, by the same value the shift will be observed in the other slip values also. Okay, so now going to the next question. Now in the next question, what you have to do is you now have to find the full load slip. So what is the full load slip? We know the new full load what you say slip. Full load speed we have to find. So full load slip is full load new is 0.14088, something like this. So your NR full load is 1 minus S times of NS. So what is this? This is 1 minus 0.1408, and this is in RPM. So in RPM means you have to do 120 F by P for getting the synchronous speed in RPM. So this is 1 minus 0.1408 into 120 into F. So I'm just hiding this because it is just coming in between. And because the system is the same as the previous question, so in the previous question the system was 50 hertz and 10 pole, so I'll just substitute 50 hertz and 10 pole. So this is 50 and 10. So if you simplify this, you will get this answer. Okay, if you do the multiplication and all that. So this is how you will get the new full load speed. Okay. Now, now what we have to do, we have to estimate the new mechanical power output at full load torque. Now you see, this is something which you have to observe carefully. They are saying now that they have already said that the mechanical power is not the same. They are saying new mechanical power. Okay, new mechanical power at full load torque. So you clearly know that the mechanical output power will no longer be 8 kilowatt. Okay, it will be something different. So what it will be, let us see. So this is equal to what? So it should be equal to your, so it should be equal, because you see the load torque is unchanged. Load torque is unchanged means your full load torque is unchanged. Okay. And what was the value of full load torque? So the value of full load torque, we have found it to be 131.438 Newton meter in the previous set of questions. But we are saying that the load torque does not change, means your full load torque does not change. 131.43, it still remains 131.438. So this is 131.438. Okay. So now, so what will be the mechanical power output? So mechanical power output is equal to full load torque. See, they are asking you mechanical power output at full load torque. They have already said full at, you have to find it full load torque. Okay. So full load torque into omega r. Omega r is in radian per second. So full load torque value we have from our very previous question, because the load torque is unchanged. So full load torque also remains unchanged. So this becomes 131.438. This is very easy to understand, right? Because what is happening in this torque slip characteristics? It is just getting shifted in the x-axis. The value of full load torque, the value of the maximum torque remains the same. However, the value of the starting torque becomes different in the after shifting by connecting the external resistance. The value of starting torque gets higher. That is why we connect the external resistance in the first place, right? We connect it so that we get higher starting torque. Okay, otherwise the full load torque and the maximum torque value remains the same. Okay, so even if they have not mentioned in the question that load torque is unchanged and all this thing, you have to understand that the full load torque and the this maximum torque remains unchanged. It just gets shifted in the x-axis. Okay. So this is into omega r in radian per second. So what is omega r in radian per second? It is 2 pi nr by 60. Nr is in rpm. So what is nr in rpm? We have found in this question 515.47. So this is 131.438 into 2 pi into 515.47 by 60. So you will get this as 7095.07. Okay. So this is the value of mechanical power, new mechanical power output. Okay. Now in the next question, you have to estimate the new starting torque. Now this is interesting. You will think that, okay, the starting torque, what about starting torque? Does it remain the same or different? It will change, because the idea of adding the external resistance is to get higher starting torque. Okay. Other torques will remain same, but starting torque will change. Only the starting torque changes when this torque slip characteristics is shifted in the x-axis. Okay. So so we know how to do that also, right? So we know the ratio of T max is K by 2, and T at starting, let us say for now I'm just writing this ks alpha by s square plus alpha square, and t at starting means slip is equal to 1. So this becomes k alpha by 1 plus alpha square. Okay. Now, if I take the ratio of 2, t starting by t max, so this becomes 2k alpha by 1 plus alpha square. And remember, this alpha is different from the previous alpha. Okay. This alpha, this new alpha is 0.675. So you have to take 0.675 for this. Okay. So this is k is cancelled, of course. Okay. So k in both the no, is cancelled. So you get 2 into 0.675 by 1 plus 0.675 square. So t starting we have to find. T max we know is same. So t max value is same as the previous question. So what was the t max value? So T max value was this, right? Maximum torque, because maximum torque is same as the previous question. This is 328.597. So we have to put here T starting by 328.597 is equal to 2 into 0.675 by 1 plus 0.675 square. So you just cross multiply here, so you will get new torque starting. So you will see that the new starting torque is 304.75, and the old starting torque, you will see it would be less value. Okay, so old starting torque was only 96.4. So by adding this much of external resistance, you get higher starting torque. Okay, so that is how you can solve this. Okay, so this is how you get solve this question. Now in the next question, what you do is you have to estimate the new full load copper loss. So what is the new full load copper loss? So we have seen that the relation between the air gap power and the, so this is air gap power minus rotor copper loss is what you say your gross mechanical power, and this is same as your shaft power, because the mechanical losses we are neglecting. So mechanical losses you are neglecting. Okay, so this is equal to this. So we have found what is the shaft power. So shaft power we have found as where is it? So we have found it as 7095 like this. Okay, so this is 7095. So gross mechanical power is 7095. This is air gap power minus rotor copper loss. So air gap power we know 3 I2 dash square R2 dash by S minus 3 I2 dash square R2 dash. So this becomes 3 I2 dash square R2 dash by 1 minus S minus 1 S 7095. So this copper loss, rotor copper loss, is 7095 into S by 1 minus S. Okay. So if you do this, you will get this answer. Okay. Now, in the next question, we have to estimate the full load efficiency. So what is the efficiency? Efficiency is P out by P in, where this is P out and P in is air gap power, and P out is the one which we have seen earlier also, 7095, which we have calculated here. Okay, like doing like this, 2 pi nr by 60 into the full load torque. Okay, so this is 7095. This is 7095 divided by air gap power. Air gap power is nothing but P out plus rotor copper loss, because there are no mechanical losses are neglected. So this is air gap power is directly equal to the P out plus rotor copper loss. So this is 7095 by 7095 plus rotor copper loss we have found in the previous question as 1163. So this is 1163 into 100 in percent. So this is this much percentage. So you can see that the efficiency gets dropped. That is why the starting resistance which we connect for getting the higher starting torque, we generally reduce that resistance once the machine has started. Okay, because you will see that the efficiency is compromised if you keep the higher starting resistance value connected in the rotor. Okay, so you will see that earlier the efficiency was more than 90%. Now it has dropped. You see, earlier it was 96.86%, but because there is resistance in the circuit and the rotor copper loss has increased because of that resistance, that is why the efficiency has dropped to this 85.9%. Okay. Now this is the last question. In the last question, we have to find the ratio of starting current and current at full load torque. We have seen this, right? So we will just take the torque. So what is torque? Torque is 3 I2 dash squared R2 dash by S by 2 pi ns. Starting torque will be 3 into starting current square into R2 dash by S, where S is equal to 1. Okay, divided by full load torque. So what I am doing is I am taking the ratio so that this 2 pi ns gets cancelled in both. So this is 3 into current at full load torque to R2 dash by slip at full load. So slip at full load, we have seen the new slip at full load was 14%. So this is 0.1408. This is 1. So this 3 gets cancelled out. Starting torque we have found now. Starting torque we have found as how much? We have obtained starting torque right now, right? 304.75. So this is 304.75 divided by full load torque. Full load torque remains the same in both the questions. So full load torque was how much? It was 131.438, right? So this is 131.438 equal to starting current square. R2 dash gets cancelled, divided by current at full load torque square, and this goes in numerator because it is 1 by this. So this is 0.1408. So what you do is, like earlier, you just cross multiply and send this 0.1408 down in the denominator and then take the square root. So you will get the ratio of the two currents. Okay. So this was the last question of this assignment. So now I'll quickly discuss the circle diagram. Okay. So basically what we do the circle diagram is, in the circle diagram, we basically want to plot how the current phasor will vary with respect to the supply voltage phasor. So let us say we have some random RX circuit. Okay. Not then we will extend this discussion to our induction machine rotor side. But here now let us say that we have some circuit with R and X value like this. So this R is variable. Now R is varying from 0 to infinity. So, but what is the value of the current? So the value of uh, so so the value of current is magnitude of current is I is equal to V by root over of R square plus X square. So let us say this is the voltage phasor. So let us say that because of this inductive circuit, in the inductive circuit, the current phasor lags the voltage phasor by theta, where this theta is tan inverse X by R. Okay, so let me just write that theta is tan inverse X by R. Okay, so this is the voltage and current phasor. If you see here, this is the voltage phasor, and current phasor is lagging the voltage phasor by theta for the inductive circuit, where this theta is given as tan inverse X by R. So if I draw the current drops in the reactance and the resistance, so you will see this IR drop will be in because resistance in the resistance, the voltage and current are in phase. So that is why the voltage drop in the resistance IR is in phase with the current phasor. Now, what about the voltage drop in the inductance? The voltage drop in the inductance will lead the current phasor by 90 degree. That is why it is leading by 90 degree, and that is why IR plus JIX is giving you the total voltage phasor as per the KVL. Okay. Now, what we will do is we will try to obtain the circle diagram. Basically, what we want to do is we want to obtain the trajectory of this current phasor. Okay, if we vary the resistance from 0 to infinity, how will this current phasor will change? Okay, so so for that, what sir did was he said that okay, let us divide this voltage phasor, all the things, voltage phasor, this IR, JIX, and current phasor by JX. Okay, so when he did that, he got this equivalent circuit. So what happened when you divide this voltage phasor by JX? If you divide V by JX, so what will happen? So this now new phasor will be lagging the previous voltage phasor by 90 degree. So this is the voltage phasor here. This will be V by Jx. Okay, this is the new position of V by Jx. What about the current phasor? If I divide current phasor, so if let us say if I'm dividing IR by, let us divide one by one. So let us say I'm dividing this JIX by JX. So if I divide JIX by JX, then what I'm left with only current phasor. So this is current phasor here. Okay, which is equal to JIX by JX. Okay, this is the current phasor. Because if I divide JIX by JX, I'm left with only I, and I is along this direction. So this is the current phasor. Now, if I divide IR by JX, then what I will be left with? I will be left with something in this direction, because this IR by JIX. So IR by JIX should, what it should do, it should lag the IR phasor by 90 degree. So that is why I have drawn it lagging by 90 degree. Okay, so this will also give you the voltage phasor. Now you see, if I change the value of the resistance, if I change the value of the resistance, so what will happen? This V by Jx will not change, I also will not change. What will change is, it only change will be this drop. Okay, so what is this drop? This drop is so this is IR by JIX. So only this drop will change. That is why in this circuit, if I fix the voltage phasor along this y axis, so this diameter V by X will remain the same, this V by X, because this is V by Jx. So if I just think only in terms of magnitude, so this is V by X. Okay, so this is V by X, voltage by X. So this is V by X. Now let us say, let us suppose you are putting R is equal to 0 in this. So when you substitute R is equal to 0 in this expression of current, so what you obtain, I is equal to V by X. So at R equal to 0, you get current phasor like this. Okay. And when you put R is equal to infinity, you will get current phasor here. Okay, at this point, because this magnitude will be, current will be 0, I is equal to 0. So it will be at this point. So you will see that the current phasor will have the trajectory in this semicircle. Okay, so depending on whether the as you vary the value of resistance, you will see from R is equal to 0 to R equal to infinity, the current will vary in this direction. Okay, from here to here. So this is the trajectory of circle diagram. This is just a pictorial way of doing things, because sometimes instead of doing calculations again and again, sometimes doing it pictorially saves time, but not in the exam. In exam, you will have to do it like that only. This is just something which is also relevant to our discussion of three-phase induction machine. So similarly here, you can extend this to the simplified equivalent circuit. So in the simplified equivalent circuit, when you have neglected the stator impedances, okay, and no stator core loss, so you have this circuit, right? So for this circuit also, you will get a semicircle in the same way. Okay, so in the same way, what you are having the trajectory of this current phasor, which is varying from this r is equal to infinity to so basically here you're not varying the resistance value, right? What you vary the value of slip. So as you vary the value of slip, so your trajectory will also vary something like that. Okay, so that is the only thing I wanted to just discuss. So that is it. Okay, these things I will maybe discuss in the next class, because I think it is too much at this point of time. If I discuss now, then everything will go above the head. Okay, so what I'll do is I will just let it be here, because it is not in the present assignment. So it is so you should not, you do not need to worry that how will I solve circle diagram related questions. It will not be asked in the exam. It is just for theoretical questions I am telling. Okay, so I'll continue the discussion for these two slides in the next class. Okay, it's very simple. Just understand that this is basically the trajectory of the current phasor which we are plotting, and you will see that the trajectory of current phasor will be in the form of a semicircle. So that is valid for any rx circuit, and it is also valid for this rotor side circuit also, because here also we have r and x only. Okay, where r is variable by varying the slip. So I think that is it for today's assignment, and next week I'll continue the discussion, okay, in these two things.
Actually, you have just 2 minutes. I just want to discuss on the quadratic equation.
Okay.
Just present my screen.
Okay, so I'm stopping my presentation. Okay, so you present your screen. Ah, yes. Huh. Hmm. Hmm. Okay. Okay. So just let me see then. Uh-huh.
It's scribble. Right? Just return the statement.
Hmm. Hmm. Yes. 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 Hmm. Hmm.
And the equation is
Hmm. Hmm.
which I
Yes.
when we do the tick process, we use
Okay. Okay.
and the higher value will be
Okay.
but
This is okay. So okay, just let me then also calculate quickly. So what you have is s square minus 4s alpha. So s square is 1. Minus 4s alpha is minus 4 into alpha. Alpha is 0.16. Okay. And this is how much? Alpha square is 0.16 square. Okay. Okay. I actually got 0.042 and 0.597. Huh? So I got 0.042. So 0.042. uh, yes. So 0.042 is less than 0.16, right? Ha, you have to take. Ha, yes. Ha, yes. So 0.042 is the correct answer. Okay. Okay.
and in exams
it is the same way what we are discussing here, and there will be some theoretical questions, not many, okay, like around 5% of theoretical questions will be there. It is for those people who are listening the sir's lectures, all the sir's lectures, okay. So but the numerical questions, rest of the numerical questions are as similar pattern as what we are discussing in the assignments, exactly same. Actually, yes, if it is numerical questions, then you will have to resolve like this. Sometimes what they will give is they will give you MCQs of the numbers, like number values. And, and also they may, for the theoretical question, there will be anyway MCQs. Okay. So for if suppose there is some theory question, like in circle diagram, they will ask you, okay, what is the circle diagram with respect to, what is the semicircle for? Uh, what is the semicircle path for? It is for current phasor, something like that, okay. So like that they will give you options in maybe numbers or the theory, okay. uh, okay, so that is it for today's class. Some of the things are left which I'll cover in the next class, so that is it, okay. So yeah, sure. Okay, then, so I'm stopping the class here today, okay, if there is no other doubt. Thank you. Okay. Chalo, thank you. I'm also leaving. You can also leave. Okay. Okay. Okay.